Today's topic is understanding C to N ratios and cover crops. And I just want to start out by saying that if you were to ask me what a C to N ratio was 10 or 15 years ago, I would have said, what are you talking about? Because I did not know. Now, whether or not it was talked in biology class, I have no idea, but I certainly don't remember and certainly couldn't have explained it. But here in the last decade or so, as I've come to understand exactly what C to N even meant, and then better yet, how to manage it, I came to realize that it's a fairly important aspect about cover cropping, and how that we need to understand this so that we can better manage our cover crops, all in the context of doing a good job of making them work for us the best that they possibly can. So just have a definition here to kind of lay down a foundation to jump off of. C to N means carbon to nitrogen ratio. So we routinely just say C to N ratio. It means carbon to nitrogen ratio. So it's a simple ratio of the mass of carbon to the mass of nitrogen in a substance. Now, the substances we're going to talk about today is primarily cover crops, but also some casual mention of our cash crops too, because they also have a C to N ratio. But just as an example here, when you'll see, you saw some of the numbers I had in my promo slide. I'm going to show that graph a little later. But example, if there's 10 units of carbon for each unit of nitrogen, then the C to N ratio would be 10 to 1. So that's just a really quick example here of what we're talking about. So it's just kind of some basic, I guess I'll call it biology here in understanding how that works. So why is this important to us in cover cropping? Well, it does have a direct effect on our nitrogen use or our nitrogen management. We're talking about nitrogen. So there's a direct relationship there that is important to growing plants. And we're all aware of some cover crops or legumes like a hairy vetch or crimson clover that actually provides nitrogen, and some are not legumes. Common ones, cereal rye, triticale, annual ryegrass, they need nitrogen to grow. So, but we're not really talking about that aspect so much today. We're talking about the carbon to nitrogen ratio as it's measured in the foliage, in the biomass. So understanding the C to N ratios can help us be better managers in the context of overall soil health and our use of fertilizer. And I think it's one of my key sentences here to understand that this is why I feel that this is important, and has been pretty much overlooked generally by and large. But when you start getting serious about making cover crops, maximizing their effect, and at the end of the day, every farmer, they want to know, do cover crops pay? Well, this is going to be part of that aspect, and how to be able to understand that aspect is critical, I feel, to be able to make good decisions and so forth. So I want to show you a picture here. This is a multi-species cover crop that was planted, that corn was no-till planted into. If you look close, you can see the skeletons of some fairly mature radishes that would have winter killed. And in this cover crop here, a large portion of this would have been winter killed. The larger stems there are sorghum Sudan grass and some sun hemp. And I don't recall exactly what was in this field. There could have been a little cereal rye or something that I burned down when I sprayed it. But I'll just make note that this particular picture right here had 0 nitrogen applied to this moment. Now, this is right when I went in and did side dress some. But I just wanted to say that you can grow corn with reduced nitrogen if you know what you're doing. And this is just an example of that. I'm going to show you a picture later on that I want you to kind of compare here of the amount of residue left on the ground and how that relates to carbon to nitrogen ratios. But just again, getting that right mix for our soils is important. And this whole carbon to nitrogen ratio discussion here, I need to mention up front, there is other factors that can influence it. The amount of biological life you have in the soil can affect the timing and decomposition and stuff like that. So I'm going to circle back around to that. The carbon to nitrogen ratio is an important component, but it's one of many variables that we're dealing with in cover cropping. So there is a lot of overlap here when we talk about what you can and cannot do with cover crops. This is just part of the equation that you need to understand to maximize the bigger picture. So one of these important components is I'm going to call it the microbe component. You could say the biological component or whatever you want to, but I just thought the microbe component sounded cool. So the typical microbes in a soil, the actual C/N ratio is around 8:1. So that's just something to know for background. And they need a diet that is near 24:1 in order to maintain optimum health. So this is important to know because we want to try to feed them a balanced diet so that we can maximize their existence, I guess you could say. Roughly 2/3 of the carbon they eat is used for energy, and the balance is used for maintenance. So this is just some background information, again, to help us understand how we can manage our carbon to nitrogen ratio in choosing the cover crops we use in the context of the cash crops we use as well. So our goal now as farmers is that we can try to manage, again, I'm using that word very clearly here, to manage to supply the ideal carbon to nitrogen ratio of 24:1. Since we know that our microbes, that's what they like. It's like, what's your favorite restaurant? Where do you like to eat? And if you go to a smorgasbord where you have choices, you're going to pick out some of your favorite foods. And you're going to be happier if you find the foods that you desire. Microbes are no different. If we provide them what they want and what they can use, they're going to work better for us. So that's kind of the theory behind all this. So the better we are at maximizing the opportunity for those microbes to process and then release the nutrients that our cash crops can use. So that's the goal. We want to do it. So, and as you can see, this ultimately does and can affect our bottom line as farmers. And that's why I'm keeping on saying there's a direct correlation here of understanding the C/N ratio and how, well, like farmers like to say, how can I make cover crops pay? Well, there's definitely something here that we can talk about in that. So a little bit more of basic understanding. This is the chart I have. You can go on the internet and find all kinds of charts with all kinds of stuff. Just to give us a little review so we understand it. And it's pretty much from top to bottom, we know that rye straw is a high C/N ratio. And I guess from I'll just say a farmer's perspective, C/N ratios can also be translated, how fast does it decompose? Now, decomposition there's a lot of other factors can enter into that. But when you're thinking about C/N ratios, you can't just say that rye or cereal rye has a certain C/N ratio because it changes dramatically as it's from the time it first sprouts to the time it's fully mature. So in any living crop, as it matures, the C/N ratio gets higher. Now, the grass type crops like cereal rye, wheat, oat straw, corn fodder, things like that. They're going to have high C to N ratios. They're more mature. There's more carbon into that in relation to the nitrogen when you break it down. And then you have our legumes, they're hairy vetch and peas and young alfalfa hay, and we can even assign carbon to nitrogen ratios to manure, and so forth. They're much lower ratio when it comes to that. So I see Jerry just mentioned here in the chat, he had a soil scientist tell him when it comes to nitrogen, the microbes eat first. And Jerry, you're a little ahead of me here. I'm getting to that, but you're right. The microbes do eat first because they're there and they can get that and they need to eat. When you're starving for a nutrient, you're going to go and get it. And that's what the microbes do. So if they're short on anything, they're going to take, especially nitrogen, which affects us, they're going to get it first. So you're exactly right. So how can I possibly achieve this ratio? And again, in agriculture, there's no absolutes usually with a lot of things, and this is no exception. So this is not an exact science, but there's a goal we have out there, and that's to supply a smorgasbord of residues that provide at least a portion of an ideal C to N ratio at any given time. So this is simply a goal that we have out there to try to accomplish, to try to do. And as we think through this in our management system, this is really what it comes down to try to set ourselves up for success, I guess is a good way to put it. So if we're using a high C to N ratio like cereal rye, that's kind of what you see in the background here. I'm going to show you a better picture next, but just if we're using that, microbes will eat any available nitrogen to supplement their diet. Well, in a mature cereal rye that in this case was rolled down and sprayed out, there's not a lot of nitrogen there for them. So they're going to be eating up any nitrate nitrogen that's in that soil profile, and your corn won't have it to grow. And we like to say that when you plant corn into a cereal rye, assume there's zero nitrogen there. And to one degree, it's because the cereal rye is taking it all up. But to another degree, because of that, the microbes don't have a lot for them to eat, and so they're gobbling up any little bit they can. There's just nothing left for the corn. So the way we manage that is we supply some supplemental N if we're going into a situation like that. So that's just a management factor there in how to do that. And I'm going to move ahead here and say how we can kind of manage around this, because there is a reason to grow cereal rye, and a lot of times it's because there's no other cover crop that's going to grow planted late in October or November. So that's like the only choice we have. Because you could say, well, just mix a legume in with it. Well, yeah, and we try to do that, but it's not going to happen every single time. So when this happens, when this occurs, we need to understand the carbon penalty. That's the term applied in a situation like this here. And it's that the microbes have taken extra nitrogen away from, or tied it up away from our crop. Now, in a good biological system, they'll eventually give it back to us as they die off and are eaten by other microbes and a higher life form. But when you are in a relatively young biological system, a couple years into this, if you're going to grow a decent yield of corn, you're going to have to supplement nitrogen on that rye. Or you could actually say you could just, feeding the microbes nitrogen as well. So I won't get more complex in that, but this is a part of the reason why you have to understand when you're planting into a high C to N ratio cover crop, the reason why there's not enough nitrogen there. So the obvious question is, or the obvious answer you could say is, well, I'll just put a legume type or a lower C to N ratio crop with it. And yes, in an ideal scenario, that's exactly what you want to do. So here's an example here. Alfalfa hay is about nearly perfect. It's at 25 to 1, which the microbes are around 24 to 1. We don't use typically alfalfa hay as a cover crop. It could be used. I've heard of people using some annual varieties of alfalfa already. But when we start thinking about planting cover crop mixes, when we mix some legumes or a lower seed to N ratio legume, then that may provide some of the best options for the microbes. A mix of hairy vetch. Hairy vetch is around 11 to 1, and cereal rye is around 37 to 1. And this is, when it's just maybe starting to head out but not fully developed. It's a typical time when you be planting corn in it. And I'm just using corn here as an example because it's popular. You can assign any other crop you grow as well. But so having a mix of hairy vetch is just a good example. It's a popular trend that addresses this dynamic. They're a nice duo. Now we can get into 12-way, 15-way mixes too, and all this factors in. But this is one of the reasons why mixes seem to perform well, because we are giving the microbes more to eat in their range of seed to N ratio. So it's again just another case for using mixes. So what we're trying to do here is we're trying to give the microbes a balanced diet, and in a way it's just like we do as humans. It's like going to a restaurant where you can go to the buffet and basically pick out whatever you want, whatever you like, whatever you need for that particular meal. So a balanced diet equals health and productivity. And that's what we're trying to establish right here in that. So Eon is asking a question here. What is the C to N ratio of a tillage radish? And does this change much as the root develops, and does the termination method make any difference? Well, you would think maybe I should know the exact ratio of it, and maybe at the end when we have questions, others can chime in. I did know at one point, but it slips my mind right now. I actually think a tillage radish would have to be fairly close to that ideal 24 to 1, but let's swing around to that later. The question about does it change much as the root develops? It changes a little bit, but radishes generally, they're just never going to have a high to seed N ratio just because of the way they are. So that in essence means they're really highly available. The microbes like them. I know that for sure. So anyway, maybe we'll have to circle around to get an exact answer on that. But anyway, great questions, and I appreciate those questions coming in. Okay, we talked about the effect of residue decomposition, and as we all know, just from observation, when you have any crop residue, it can be all the way to a high C to N ratio, like let's just say a tree. See, a tree, depending on what type of tree, may be 1 to 300 parts per to C to N ratio, or like 100 to 1, or even up to 300 to 1. It will eventually decompose, but it might take decades actually. Whereas you can have something like a hairy vetch that's terminated right at first bud stage, that can pretty much decompose in maybe 6 to 8 weeks. So that's a direct relationship to the C to N ratio. So as something is out in the atmosphere, how does this happen? How does the residue decompose and to a point where the microbes can utilize it? A lot of it is affected by the weather, and in a large part, the moisture. The more regular moisture you have, the more consistent it's going to decompose and be broken down. Temperature can have an effect as well, and generally when it's very hot, generally it's dry, that affects the moisture. And then also, of course, when it's frozen or very cold, you're not going to have too much decomposition at that point. So over time, there's huge differences in this, and the amount of soil biology, or we could say microbes, that happen to be in that given soil can dramatically affect the rates of decomposition. And I have certainly learned that well here on my farm. And my farm has evolved over decades, I'll say, of increased microbial and more soil biological life in the soil. So here's just an example. This happened to be from a planting green plot that we did working with Penn State University, where we sprayed out cereal rye when it was about 20 inches high, and then we left it grow 2 more weeks till it got about 4 feet tall. So the C to N ratio on the right side there is going to be much lower than the C to N ratio of the more mature rye. Now, just to tell you an average scenario here, and I don't have a picture of this exact spot to kind of give a comparison, but on the right, since it was terminated at a more or a lower C to N ratio, probably like 30 to 1, I'm just going to guess, that's probably going to be all decomposed in my environment here, where we do get 40 inches of rainfall a year. That side will be decomposed by about the 1st of August. Whereas where it's green now and would be terminated at that stage of growth, that may not be decomposed for a full year. It may lay in that soil surface and not be decomposed. So in the meantime, understanding that ratio and how the microbes work is important. Now, I kind of learned a lesson in this is back now in 2011 with this next slide coming up here. We had planted a 12-way mix in the fall of 2010 after wheat, and you see that picture there on the left, beautiful stand, 3 to 4 feet high. It just looked awesome. I was going to plant corn, so we had the radishes in there, very little grass, some sunflowers. You can see there was some legumes in there growing as well, some hairy vetch and some crimson clover. Then on the picture on the right-hand side is planting that field next year. And I'm telling you, nothing was done to that field. It was not even rolled. But if you look there, you can see there's hardly any residue left. And that's because the soil biology, the microbes, came up and ate it off. Now, if I would have, and here's how the soil surface looked. I was literally embarrassed that year to show people who came to tour my farm. And here, I had this particular field was essentially bare. Very, very little cover at all. Now, obviously in the fall it was covered well, but you know what? The C to N ratio of my cover crop was too low for what I was trying to do in the context of my field and the soil biology that I had. So if I would have been in another situation that it may be a field that was just starting to no-till or just starting to get into this more use of cover crops, that residue may have had up to 100% coverage at that point, simply because there may be no or very little biology there to break it down, very few microbes to be there. So the reason I'm bringing this aspect into the C to N ratio discussion is it's more than just the C to N ratio of a cover crop. Because we can look at the books and you can stand there in the fall and you can look at your field and you say, oh, I think I have a C to N ratio of whatever. And that is absolutely true. But in the context of management, you have to manage your C to N ratio according to the biological aspect of your soil. And you may not, that's why you have to do the experimenting and the research on your farm. Because I could take that same exact mix and put it on another field, like I said, and it may be 100% coverage on the soil. And we're striving to have 100% coverage on the soil. Now, in one sense, I did joke around and say, well, at least I had almost 100% earthworm castings. And I see Brent Jones just chatted in here. He says, looks like a lot of earthworm castings. You betcha. You betcha. That is almost 100% covering of earthworm castings. And that just proves my point. But now, what I had to do to be able to manage that on my field, on my farm, was change up the species to get higher C to N ratios. And here is a result of that. This is just 2 years later, same picture I used before. Now this is what works for me. So I'm just bringing this aspect in because you can't just talk about C to N ratios by the book and apply them to any field. You use that as a starter, and then you see how it works out based on the microbial population, earthworms, and all that stuff. So that's the little twist I felt was important to bring in to this whole discussion here. And then we get the question, but doesn't tillage aid in residue decomposition? And those of you who know me well, I'm a 100% no-till farmer for 22 years here on my farm, but that doesn't mean I'm telling everybody else to do that. I understand there's need for tillage, and there's understand to, taking people from where they're at. I will also be very adamant that we need to use as less tillage as possible. Yes, tillage does factor decomposition because it literally breaks up some of the residue and it puts it into the soil where there's more moisture, and it can, aid in that breakdown and so forth. But tillage also kills, or at very least beats up on the microbes and the earthworms, the very critters that are trying to not only survive, but do their part in a biological system. They're trying to work for us, and we need to try to manage them to be able to do things for us that actually help us. So if we leave them undisturbed and we provide them food, we try to give them that 24:1 C to N ratio, that smorgasbord diet that we as humans like, then they're going to thrive, and they'll provide us as farmers with many nutrient cycling benefits. So again, that's the theory behind all this. That's our goal. That's what we're trying to do. So again, coming back to the question, I've talked about economics a couple times. What are the economical benefits of getting the C to N ratio right? Well, some of it is somewhat implied, but I'll just say here that in the short term, optimal nitrogen use. Now notice I didn't say less nitrogen use. Now, if we're talking using a low C to N ratio crop like hairy vetch that actually provides nitrogen, yes, lower nitrogen use. But if we're talking about a new field that we're trying to adopt these principles, and we're going to plant corn in that, and we had to plant cereal rye in the fall, you may have to use more nitrogen in order to grow a corn crop that is actually economical profitable. I could probably show you data to back that up. So that's why I say optimal nitrogen use. Now, I will tell you that over the long term here, you see the points laid out there, higher organic matter, lower purchased nitrogen and other units. I can promise you it'll be lower. I'm not going to promise you how much lower, and I'm not going to promise you no nitrogen or other nutrients. I'm just telling you worldwide, it's a worldwide phenomenon. Once you get into this, and I'm talking into the 5 to 10 year time period, you can start, and I like to say earn the right to lower some of those purchased inputs. Microbes are happy. They're providing many benefits for us, and that's all associated with cover cropping. I'll just make a note. This is my neighbor's field here. Happened to be after wheat, so he got a great stand of a mixed cover crop. In our area of the world, most farmers like to do double crop soybeans after wheat. In this case, he planted that multi-species cover crop, and he did planted corn the following year. It would have been 2017. He planted corn. He did a test in there, a very good replicated test, and where he did not have any nitrogen applied, he had over 250 bushels of corn. Where he applied 60 pounds of nitrogen, it was either 50 or 60 pounds of nitrogen, he only increased his bushels, I think 4 or 6 bushels per acre. It was very negligible. Now, this farm, to be fair, has had a history of the use of manure and so forth, so there's a lot of good, it's a good soil. But typically, he would have put 100, 150 pounds of nitrogen on in this scenario. And so that's just a case where when we manage this C to N ratio right, then we can start, literally making some money as farmers. So there is a lot of science behind this, and there's a lot of information out there. I am going to send a link or two around put it on the Facebook group and also in the webinar link for this. So if you want to look into it, but it can be somewhat complex. C to N ratio is a little hard to describe in one or two sentences, and I think that's why it hasn't been well known. But there's a lot of good information out there, and when I was looking into this the past week here, getting ready for this, I came across a recent article that was written by none other than Don Donovan, who is actually on this call. So appreciate Don that, because it helped me to brush up your article. And I'm going to send the link to this out, but I think it's really cool to see people that are members of this group here, the Cover Crop Innovators group, who are out there making a difference. And we all have our ways of making a difference, but I just thought it was cool that I could use some of the information that Don had to be able to share today. So thank you so much, Don, for that, and I'll send that link out to everybody in the email that comes out here. So just in summary here, and let's get, you can get ready to ask some questions here in a second. This is my last slide, but don't get hung up on all the technical aspects of targeting ideal C to N ratios. It's more about, if you're going to do this like automatically, if you manage for diversity of plant species. That's a loaded bullet point there, because I'm not just talking about cover crops. I'm also talking about diversity of cash crops as much as possible. I understand limitations, but start to think about how you can mix things up. That is very, very beneficial. And then reduce tillage as much as possible. I was tempted to put no-till in there, but I'll just say reduce tillage as much as possible. No-till when you can. The microbes are certainly happier, with a few exceptions, but generally we want to reduce our tillage as much as possible. So that's going to set you up for a better opportunity for long-term soil health benefits and profitability. So that's my take on the carbon to nitrogen ratio. I'm going to open everybody's mic up, and I would love to hear some discussion on some questions here, and also input if anybody wants to have input. So who has a question that we'd like to ask?
Steve, this is Jerry Hall. I don't have a question, but I just want to reiterate something you just touched on and emphasize it more. When figuring out the CN ratio, it's really important also to consider what your cash crop residue is, what you're dealing with. So like if you've got a lot of corn stover on the ground, you might want to go and err more on the end of a low CN ratio than a high CN ratio, because you've already got a lot of high CN ratio material on the ground.
Correct. Yep. Good point. Good point. Yeah, because, the soil, the microbes, they don't know what's a cover crop and what's a cash crop. So you're exactly right. It's the total package there. Other questions?
Steve, it's Don.
Yeah, Don.
This is Don. I was going to add a comment to that. But at the same time, we know that ahead of corn, we need nitrogen, and ahead of beans, soybeans respond to a nitrogen-deprived environment. And so if you're going ahead of beans, you may want a really, really high carbon to nitrogen ratio, so you starve that soil of nitrogen, because the beans can respond to that and start nodulation quicker and start nitrogen production quicker. So and it's kind of a management thing with your cash crop.
Exactly, and I think that's one of the reasons why soybeans seem to do consistently well across broad areas planted after a cereal rye. That's probably one of the reasons there, Don. That's a very good point.
Without question. And if you're going soybeans after corn, I don't think you have a real concern with soybeans after corn. Now, if you're planting corn after corn, then you're going to have to deal with that.
Right.
That you've got to really be concerned about that, because you're going to have to front load some nitrogen somewhere.
Yep. Other questions or comments?
Did you see my note that I put on the chat?
Yeah.
When you were talking about tillage,
Yeah, I'll just read it here. You had Don says he has a picture of a piece of residue taken from a foot in the ground in a field that had been no-tilled for almost 10 years. The earthworms eat on the surface, not below. You want to comment a little bit more on that, Don?
Well, we were digging a pit for a soil health day, and we found some residue in the soil. So this whole idea that burying it makes it go away faster is a myth.
Okay.
And the first breaker downers of big residue are earthworms. Earthworms eat on the surface. They do not eat below the surface. They come to the surface, they pull down the residue, and they also, they keep their backsides in their midden, and they don't come completely out of their midden. Mm-hmm. And so you need the soil completely covered. I've been in fields in September when we're walking to pull stalk samples for nitrogen testing, where in a good no-till field, you'll see the middens everywhere, and there's no residue small enough for an earthworm to use, and they're already starting to pull corn stalks down in and strip the residue off the corn stalks, and all they have left is the spine.
Yep, I've seen that.
And you may see 10 corn stalks pulled into a midden.
Yep, and that's exciting.
So we got to feed we got to feed the start. We got to feed the macrobiology so they can help feed the microbiology.
Yep, exactly. Other questions or comments?
I did look up a little bit on the CNN of diconradic.
Yeah.
It's somewhere probably between 15 and 20 to 1.
Okay, that sounds about right. Well, thanks for doing that. John Johnson, do you have anything to say? I see your mic's on.
Great presentation. I think prescription planting of cover crops is the next wave in managing the carbon to nitrogen ratios. I really do. I've given a couple talks, and they asked me what the future holds for, and that's what I suggest.
So you're saying prescription, basically what you're saying is having the C to N ratio is as a determining factor for planting cover crop species. Is that what I hear you saying?
Yes.
Good.
Yes.
Yeah, I agree. Yep, I agree.
Steve, this is David Lamb.
Yes, David.
How do you factor that into your, when you're trying to decide your nutrient rate for upcoming year? How do you play? Do you have like a rule of thumb, or are you using any tool? I know there's several efforts out there to kind of track the mineralization effort or mineralization that's taking place.
Yeah.
You got any rule of thumb that you're using?
Well, I think maybe you're getting at some of the soil health tests that are out there kind of have this kind of as a factor, I'll say, as one of the variables indirectly maybe. Actually,
I'm thinking about, like the thing that Cornell has with their, I can't remember what they call their spreadsheet or their in-season estimator. And I know that the University of Georgia working with the Southeast Cover Crop Council trying to come up with a mineralization tool. I'm just curious what your thoughts are on that, and what are you using when you're making a determination?
Okay, here's my thoughts, and I'm not saying they're correct. My thoughts are it all comes down to what works on any given farm, or maybe down to the field level. And I don't mean to be snarky, but I have literally done thousands of plots here on my farm over the years. And if there would be a clear consistency on these things, you would know about it because we'd be yelling it from the rooftops. There are so many variables in all these subjects we have with cover crops that it is impossible to take fine-tuned details and to prescribe them in any highly reputable, replicable manner. So to answer your question, I have become comfortable with what I've seen in my fields based on all the research I've done. And no farmer, very few farmers are ever going to do that much. I mean, we put out, one year we had 700 plots testing nitrogen rates with different cover crops. 0, 50, 100, 150, 200, and replicated multiple times. And out of that, we learned some things. Absolutely, we learned some things. But I can't even, with confidence, tell you what worked on my farm is going to work on even my neighbor's farm, let alone Illinois or Saskatchewan or Oregon or the UK. Now, within a percentage of maybe 60 to 70% accuracy, yeah, I could say this is basically what you may expect. But to take it to the level that John was talking about here, prescriptive, that's going to have to come down to every farmer is going to have to do some playing around with this on their own farm. And, that's my answer. I know it's not an answer really, but I don't want to get any wild expectations out here that if you understand C to N ratios, you'll all of a sudden be able to manage everything to, like clockwork. So my answer to your question, David, is every farmer is going to have to embrace some of this and see what works on their farm. That's my answer.
Well, Stephen, that's what we would call that adaptive nutrient management.
Okay.
And kind of working towards that. I'm just kind of curious. So, again, that idea of we're encouraging on-farm, not maybe replicated plots, although our standard would call for that.
Sure.
Work. What would you say would be a reasonable amount of that type of work to do for some of the people you work for? A guy who farms 1,000 acres out there. I mean, do you need every field? Do you need representatives, 2-3 fields, or because that's very that can be very time consuming and laborious too, which is probably why it's not done a lot. Because it does take quite the effort.
And I want to have a topic here, how to do on-farm research here, coming up in the next 2 or 3 months at least for sure, and I'll get into that. But just really to answer your question now, if a farmer has, let's just say, 100-acre field, and he plants a cover crop mix in it, let's just say whatever that mix is, and if it's corn, which is the easiest one to talk about, and I would take what he thinks his nitrogen rate should be as kind of your one of your treatments, and I would do one treatment 50 pounds higher or 40 pounds or whatever he wants to do. And then I would do one 40 pounds lower and then one even lower than that yet. If he can put 4 treatments out, that's nice. And ideally, and this is where it gets a little complicated, you can replicate it. But once you understand how to do this, when you have GPS and you can lay out 4 paths of, like, let's just say 100 pounds nitrogen and another 4 paths of 150 pounds nitrogen, you write your flags out beforehand. And you have someone with you, you stick the flags as you do the plots, and then you can come back in, and if it's big enough, and you trust your yield monitor that's pretty good, you can just take those plots off, and it really only takes about 15, 20 minutes of your time, because most of these guys, they can adjust their nitrogen rates on the planter now from the tractor cab. So even if you don't have that technology, it doesn't take long. I would say if you take 1 hour out of your day, out of your year, you can get some pretty good data on your farm that may equate to thousands of dollars, may equate to that. And I would suggest, just like some farmers are very aggressive at testing new varieties, they understand how to do this stuff, and they can just do it. So that's my short answer to that, but I think I'll have a whole topic on it at some point, David, on how farmers can actually test this.
Yeah, that'd be a good topic, because I think a lot can be gained. We tend to discount farmer research, if you will, but yet that's really the next, how you can really fine tune it to your own particular operation.
Well, I'm a farmer, I can say this. There's reasons to discount farmer research. And we all hear the guys say, well, that corn looked like it was 20 or 30 bushels better. And they don't really know. They really don't know until you replicate. I have done enough research to say that things will surprise you until you get replicated and all that. So suffice for that topic for now. It's an excellent topic, but in testing some of this stuff, on-farm research is really the best if you do it right. And there's plenty of people on this call here. There's plenty of people out there. And I think, David, you're with the NRCS. That's a role that the NRCS can really step up and have been done, by the way, but really step up to help farmers do this kind of research. So maybe I'll just give you that little challenge to keep that up as the NRCS to help farmers do their own research. And I'm sure you agree, David, because I know where you're coming from, but keep up the good work on that end. And yeah, we got other people on here too with the NRCS and so forth. So I'll just put that out there as a little challenge to help with that. Other comments? Questions? I don't mean to put you in the spot, but Joy, do you have anything to say? You're involved in selling these seeds. Any comments? Any questions you get from farmers? Anybody else? I know, Jerry, you're up in this here kind of a topic. Any other comments you have? Well, if there's anyone, just feel. Yeah, go ahead. Go ahead, Jerry.
I just said no. I think you covered the topic real well. I think once guys get a handle of CN ratios, it really changes the way they look at things. Mm-hmm. I know it did for me.
Yeah, certainly did for me, as you could hear. Other comments on this topic?
I think I appreciate your comments about, you kind of hit on the yield drag for early no-till adoption.
Yeah.
I think that's something we overlooked a lot, and I thought you did a good job hitting on that. That's something we try to bring out in our training, that you need to be patient and look at the system and see how that whole scenario works out.
Yeah.
And I think it's another misconception. I know early on when we talked about nitrogen tying up in the residue that, we never really thought about the biological tie-up. It was somehow we were thinking about the residue being a sponge, and it was being held in that, matrix of residue rather than being part of the biological biomass there. Yeah. So I think that's something that we need to really continue to address.
Yeah.
So how those two are linked together.
Yep. Well, I just put up on the screen next week. We're going to talk about spring planted cover crops. So that's very timely here to be thinking about that potential possibility. So that's the topic for next week. And but I'm opening it up here now for any other topic other than this. If there's another cover crop topic and at all, any cover crop question, we got a couple minutes left, about 9 minutes left to discuss anything you want. But Eon from the UK asked here, do you have a...
Can you hear me now, Steve?
Goes that?
Can you hear me now?
I can.
So my microphone wasn't working, I don't think.
Okay.
Yeah, all it was I was wondering about the mix itself. Obviously, you want to try and get a range of CN ratios within the mix rather than have a lot of low ratio and then some high ratio. You want some mid-range in there as well to sort of balance out the feed availability during the decomposition period. And I mean, do you have a standard thing that you would use routinely, or do you vary it a lot from year to year, crop to crop, that kind of situation?
Well, I'd answer it this way. It varies more on the time of year that it is planted. When is your planting window? So, the summer type species, you have so many options. And then as you go out into fall or autumn, then the options greatly are reduced. So I'll just tell you some popular ones that seem to be popular here in the States. If you have a time in the fall, the end of September, beginning of October, well, I'll just say the end of September, a radish, a crimson clover, annual ryegrass tends to be pretty popular. You can mix some triticale or cereal rye with that. Cereal rye and hairy vetch is a really good combination. But when you get into the summer, then you talk about those 6, 8, 12, 15-way mixes. Those mixes generally have like a sorghum Sudan in them and a sun hemp or a cowpea, and maybe a radish even early, because the radishes tend to be underneath the canopy and they come to life a little bit more in the fall. Now, I've been to Europe multiple times, and over where you guys are, you guys use more fava beans and phacelia and sunflowers and things like that. And so I would say there's not a go-to mix. It's more what your region has found to work. So I think that answer is pretty diverse. What is working in your area now?
I've certainly found that we did some trials where we grew all of the constituents on their own as a demonstration plot for each one.
Yep.
And then grew them as a mix.
Yep.
And in the solitary plots, some of them failed completely.
Yep.
Some of them grew reasonably well, and some of them grew very well.
Yep.
Without exception, and I mean not one single exception, everything grew better in the mixed community, in the mix.
Yep.
And most things grew much better. Rather than compete with each other, they just have a synergy, and they just seem happier as a consortium rather than on their own. And we were struggling to explain it. It's fairly new to us, but there's nothing like believing what you see.
Yeah.
And there was quite a lot of excitement amongst the farmers there that this had really happened, and not to a sort of minimal amount. It was quite remarkable, the difference in the mixture. I think we had about 9 things in the mix, but it was incredible.
Oh, I've heard that story shared very often. That's literally a worldwide phenomena, and that's so cool that you see it and it works in your area. And then you ask the question, like you just asked, well, how can we improve in that mix? We know it's good, but how can we improve on it? And that's the never-ending question. That's something that we just continue to look at. I don't see that question to be fully answered ever in the horizon, because
it would only be possible if we knew what the weather was going to do.
Well, that too, and we don't, and that's partly why we gave that answer. Because, but that you bring up a good point. At least when you have a mix, you're prepared for all kinds of weather extremes, because some species will do better dry, cold, hot, wet, whatever. And that's another, certainly another aspect for mixes. So I'll leave it at that.
Yeah.
That's a very good observation. I'm really glad to hear that you're seeing what we see as well. And I'll just tell you a quick story. I used to test all kinds of cover crop species as single species. And then when I got into the mixes, then I thought, well, I need to be testing cover crop species in the context of a mix, not in the context of single species. Well, all of a sudden, it makes many more challenges to do that. But still, and I shared this at one of my other webinars, where in France with Frederic Thomas, they actually did this crosswise pattern with mixes when they planted a plot, so that they used various mixes, like 10 or 12 mixes, and then they planted them at half rates, and they planted them up and then turned around 90 degrees and planted them across. So every single mix was replicated 2 times where it overlapped with the other mixes. And that was very interesting to walk in that plot and see the dynamics that go on between mixed species and mixed species. So, again, we have a lot to learn, but that's what I love about this whole topic here, because we're never going to figure it out in our lifetimes, probably. So,
one of the best things that someone said at these meetings was the only place he'd ever seen nitrogen deficiency was in a farmer's field.
Is that right? Well,
because you don't see it in nature. In nature, it doesn't happen.
Yeah, that's an interesting. I've always said too. When you look at a woods or a forested area or a prairie, you just don't see disease. And you don't see nutrient deficiencies. Why is that? And I think to answer that question, how can we mimic that in our crop production areas? And that's, again, what we're all trying to do. So that's a great observation. Anyone else have any other questions? We'll take one more.
Hello, Frank. Hi.
Hey, go ahead.
Mm-hmm.
Go ahead. Someone else have a question?
No, I just
yeah, go ahead, Derek.
I just seen that synergy between your multiple species growing together, and then just seeing it driving around anywhere you go. On the pitch bank, on the river, wherever. I mean, that's what it really piques my interest. I mean, it's really fascinating, and then
easy working for them.
Yeah, and that's what I really want to try to challenge myself to try to apply that, like in the crop growing, the companion crops. I think would really be cool. It presents a lot of challenges though.
Yeah, well,
it's really awesome to figure something out.
I heard from someone about miscanthus nurseries as well yesterday.
Okay. Well,
I mean, they always have.
Well, okay. There we go. Sorry about that. I had to mute that there, right there. But well, anyway, hey, thanks so much for your participation today, everybody. I look forward to next week. And again, thanks for everything. Have an awesome week.
Thanks, Steve.
You're welcome.